Okay, the next test is called the nth root test. Nth root test. Okay, and here we don't need another series to determine whether our series is convergent or not. This, according to this test, if for a series like this, a of n from 1 to infinity, and if instead of 1 we got, for instance, 1000, that doesn't affect the convergence of the series. Okay, because this is just a tip. This is equal to this an minus 1 n equals to 1000. Okay, this is just a number, even if a be divergent, this is just a number, the sum of the series for the n equals to 1 to n equals to 1000. Okay, and this is the series which start at usual n equals 1. Okay, anyway, let's say the usual n equals 1. Okay, and now the test says that if the an's be positive and the limit of the nth root of n, when n goes to infinity, be smaller than 1, then this series converges, and if this be greater than 1, this would diverge. And if this limit be equal to 1, this test doesn't work for this case, and we should use the other tests or methods. Okay, and now one application of this is for the solving the differential equations I talked about before, which we got an infinite polynomial like this: a0 plus a1x plus a2x squared plus ... Okay, and here the general term is an x to the power of n. That's before that, if again the an's be not necessarily positive, then you could try this, the absolute value of an, as a new series, and in this case you should calculate the limit of the nth root of the absolute value of an, and if this be smaller than 1, then this converges and the original series also converges. And I was saying that the general term of the infinite polynomial is like this. So we need to know that whether it is convergent or not. So using this test makes things easy. And here ANs and this might not be positive. Okay, so we could work with the absolute value of this. Okay, and now use this test. Take the nth root of this, which would be what? Which would be the nth root of an, or the absolute value of an, times the nth root of the absolute value of x to the power of n. Which is the absolute value of x itself. Now, if this exists, the limit of this, let's say this is L. Okay? Then, in order to the infinite polynomial be convergent, it should be smaller than 1. This is the limit of this. It should be smaller than 1. And, this doesn't depend on n. Okay? It is just a constant here. It is not a real constant, but it doesn't depend on n, so that would be equal to L times the absolute value of x. Okay, and this should be smaller than 1, so the absolute value of x should be smaller than 1 over L, which is the limit of this, which itself is, if the limit of this exists, an, let me this is the absolute value of the limit of an. Let's call it the little l. The nth root of this. Okay. Anyway, so the series converges for the values of x which be the absolute value of them be smaller than 1 over L, or the values of x which be smaller than 1 over L and greater than minus 1 over L. Again, out of screen, 1 over L minus. Here also on the screen, 1 over L. Okay, so Okay,